Assalamu alaikum students, how are you all? Hope so you are good in your sweet homes. Wherever you are, the sincere wishes of your teachers are with you. Students, today we are going to take start from question number 4 of exercise number 1.5. In this question, you are given a matrix A and entries are 1 to 4 and 6. We have to prove that A into adjoint of A is equals to adjoint of A into B. Means we have to take adjoint of A first and we have to multiply it with A with from both sides, left and right, and then we have to prove that it is equals to determinant of A into I. I means identity matrix. Now we are going to prove it. First of all, we will find adjoint of A. And you know how to find adjoint of A? Adjoint of any matrix. This is adjoint of A. You have to change the places of the diagonal entries 6 and 1 and signs of the non-diagonal entries -2 and -4. Okay, now we will multiply this adjoint of A with A. A into adjoint of A. It's mean first I have to put the matrix A, then adjoint of A. Because you know commutative law in matrices does not hold in general. Okay, now this is the matrix A and this is matrix adjoint of A. 6 -2 -4 and 1. Now we'll multiply it, and you know how to multiply the entries. First row will be multiplied by first column and then the same row will be multiplied by second column. That will be 1 multiplied by 6 plus 2 multiplied by -4, and here it will be 1 multiplied by -2 plus 2 into 1. Okay. Similarly, we will solve the second row. 4 into 6 plus 6 into -4. 4 into -2 plus 6 into 1. And when you will solve it, this will be 6 plus minus minus 4 into 2 is 8. 6 minus 8, it will be -2 plus 2. It will be 6 into 4, 24 plus minus 6 into 4, 24. 4 into -2, -8 plus 6. Okay. Now when you will solve it, it will be -2. 6 minus 2 plus minus sign will be of greater value. Plus 2 minus 2, 0. Plus 24 minus 24, 0. And -8 plus 6 is again -2. Now I will solve this side. Means I will first put adjoint of A, then matrix A. So just I have to change, like I will write the adjoint of A first. 6 into 1 and -2 -4, and it will be adjoint of it will be A. 1 6 2 and 4, and here also I have to change it. Adjoint of A is going to be multiplied by A. Okay. Now obviously I have changed their sequence, so complete multiplication will be changed. Be careful if it is written adjoint of A into A, so you have to put adjoint of A first, then the matrix A, right? Again and again I am telling you, commutative law in matrices does not hold in general. Okay, with the same procedure we will multiply these two matrices and we will get the same answer. 6 into 1 plus -2 multiplied by 4. 6 into 2 plus -2 multiplied by 6. -4 multiplied by 1 plus 1 into 4. -4 into 2 plus 1 into 6. Okay, now we will solve. 6 into 1 is 6 plus -8. It will be -4 plus 4. It will be 12 minus 12, and it will be -8 plus 6. And now look, what is the answer? minus 2, 0, 0, minus 2. It is same as of this. Now the last value is there, determinant of a into I. Now we will solve this side and it will be equals to the same one. Now determinant of a is equals to, first straight line should be there, 1, 2, 4, 6. Okay, how you will take the determinant? Product of diagonal entries minus product of non-diagonal entries. So it will be 6 minus 8, which is equals to minus 2. Now we will solve this, determinant of a into I. This is determinant of a and I is the identity matrix. Sorry, it is 1. Okay. Now this minus 2 will be multiplied by each and every entry of this matrix. Minus 2 multiplied by 1, minus 2. Minus 2 multiplied by 0, 0. Minus 2 multiplied by 0, 0. Minus 2 multiplied by 1, minus 2. You can see all the sides are equal. So we can say hence proved. And what we have proved? We have proved A into adjoint of A is equals to adjoint of A into A, and it is also equals to determinant of A into identity matrix. Okay students, now this is the second part of the same question, that is B into B inverse is equals to identity matrix and which is equals to B inverse into B. Means according to this question, first of all you have to find the B inverse and you will multiply it with the same matrix B from left and right side both, and you will get the identity matrix. And the matrix B is given, that is B is equal to 3, minus 1, 2 and minus 2. Okay, first of all we have to find B inverse, and you know, for finding the inverse, what is the formula? B inverse will be equals to 1 by determinant of B into adjoint of B. Okay, first of all, for solving this formula, we have to find the determinant. 3 minus 2, 2 minus 1. And for determinant, what we have to do? Yes, product of diagonal entries minus product of non-diagonal entries. Okay, it will be equals to minus 6 plus 2, which is equals to minus 4. And minus 4 is not equals to 0, therefore it is not a singular matrix and inverse is possible. Next we have to find the adjoint of B, and for adjoint we have to change the places of diagonal entries. Minus 2 will be here and 3 will be here, and sign of the non-diagonal entries, minus 2 and plus 1. This is adjoint of B. Now we will put this in the formula. B inverse is equals to 1 by minus 4, and if there is minus in the denominator, we can shift it in numerator in standard form into adjoint of B, which is minus 2, 1, minus 2 and 3. Now students, we have to multiply this B inverse with B from both sides, from left and from right as well. Okay, now in the next step we will solve this. Okay, now students, we will multiply with the same procedure by putting B inverse first and then B. Like B inverse into B, which is equals to minus 1 by 4, minus 2, minus 2, 1 and 3 into B, 3, 2, minus 1 and minus 2. With the same procedure, we have to multiply the two matrices. first row will be multiplied by each and every column. Minus 2 will be multiplied by 3 plus 1 multiplied by 2. Minus 2 multiplied by minus 1 plus 1 multiplied by minus 2. Minus 2 multiplied by 3 plus 3 multiplied by 2 and minus 2 multiplied by minus 1 plus 3 multiplied by minus 2. Okay, minus 1 by 4 and now what will be this? Minus 2 into 3 is minus 6 plus 1 into 2 is 2. Minus 2 into 3 is minus 6 plus 3 into 2 is 6. Minus 2 into minus 1 is plus 2, minus minus plus, and plus minus minus 2. This will be minus minus plus 2 and plus minus minus 3 into 2 is 6. Okay, now minus 1 by 4, it will be equals to minus 4. Minus 6 plus 2 is minus 4. Minus 6 plus 6, 0. 2 minus 2, 0. 2 minus 6 minus 4. And now you will multiply this minus 1 by 4 with each and every entry. Minus 4 will be multiplied by minus 1 by 4. 0 multiplied by minus 1 by 4. 0 multiplied by minus 1 by 4. And minus 4 multiplied by minus 1 by 4. Okay, now again minus minus is plus, 4 and 4 cancel. What is left? 1. 0 multiplied by any value, 0. 0 multiplied by any value, again 0. Minus 4 and this is plus, minus 1. Minus 1 minus plus, 4 and 4 is cancelled, that is equals to 1 now. And this is also the identity matrix. Students, today question number 4 is enough for you. So we are just doing question number 4 both parts, but you have to do a lot of practice of these questions, because in these questions multiple topics are there, like adjoint, determinant, inverses, and how you have to multiply the different matrices. Okay, you should have a complete command on these topics so that you will be able to do chapter number 1. Wish you best of luck. Allah Hafiz. Okay, now we are having these two matrices, B inverse and B. Now we have to multiply it according to the question. Firstly, we will find B into B inverse. B into B inverse. So B is the first matrix. We have to write B matrix first. That will be 3 minus 1, 2, minus 2. And second matrix is B inverse. Friends, here we have to use this bracket for minus 1 by 4. Why? Because if I am not putting these brackets, it's mean the new term is going to be started like this. You can see this minus will indicate that the new term is going to be started. And in fact, these are multiplying with each other. That's why the bracket is important here. Okay. Now the B inverse value is minus 2, 1, minus 2 and 3. Here students, we can do one thing, that is minus 1 by 4 can be at the one side, and first we can multiply these two matrices. It will make your question more easy to solve. Minus 1 by 4. Now with the same procedure, we have to multiply these two matrices. Row will be multiplied by each and every column 1 by 1. 3 will be multiplied by minus 2 plus minus 1 multiplied by minus 2. 3 multiplied by 1 plus minus 1 multiplied by 3. Similarly, 2 will be multiplied by minus 2 plus minus 2 will be multiplied by minus 2. 2 multiplied by 1 plus minus 2 multiplied by 3. Minus 1 by 4, and it will be minus 6. Minus minus plus, it will be plus 2. minus 6 plus 2. It is 2 multiplied by minus 2 is minus 4 plus minus minus plus 2 into 2 is 4. Now here it is 3 plus minus minus 3 into 1 is 3. 3 minus 3. Here 2 into 1 is 2 plus minus minus 6. And now it is minus 4. It will be 0. It will be 0 and 2 minus 6 again minus 4. Now this minus 1 by 4 will be multiplied by each and every entry of this matrix like this. Minus 4 multiplied by minus 1 by 4. 0 multiplied by minus 1 by 4. 0 multiplied by minus 1 by 4. Minus 4 multiplied by minus 1 by 4. Clear? Okay. Now this is minus minus plus. 4 and 4 will be cancelled. And what will be left? Yes, 1 will be left. 0 multiplied by any value is 0. 0 multiplied by any value is 0. Minus minus plus and 4 cancel and 1 is left. And it is equals to identity. Similarly, when we will solve by putting B inverse first and B after this, then we will get the identity matrix.